In this video, we're going to look at some examples of doing stoichiometry with thermochemistry. In this particular problem, we want to know how much heat is released by the above reaction if 175 grams of oxygen react with excess zinc sulfide. In order to solve this problem, we need to be aware of what these thermochemical equations tell us. In this particular equation, it tells us that when 2 moles of zinc react with 3 moles of oxygen, that will produce negative 879 kilojoules of heat. And so I can write conversion factors that relate any amount of reactant or product to the heat that's produced. In this case, we're interested in the reactant oxygen, and so my conversion factor is going to be that 3 moles of O2 are equivalent to negative 879 kilojoules. And so using this conversion factor, we're going to treat this just like any other stoichiometry problem. So I'm given the mass of oxygen gas. I need to get it into moles using the molar mass, and then I'll get from the moles of oxygen to the heat that's produced using this conversion factor. So what this is going to look like is I start off with my 175 grams of O2. I'll divide by the molar mass. Molar mass of O2 is 32 grams per mole. All right, so at this point, I'll have converted my starting 175 grams of O2 into moles of O2. So now I'm going to use this conversion factor to go from moles of O2 to the heat that's produced. So I'll have 3 moles of O2 down here, the negative 879 kilojoules. So my moles of O2 will cancel. I'll be left with kilojoules, which is what I'm looking for. And when I multiply that out, my result is negative 1,602 kilojoules. I can only have 3 significant figures in my result because I only know the mass of O2 to 3 significant figures. So I'm going to write that as negative 1.60 times 10 to the third kilojoules. All right, we'll do another example with this same chemical reaction on the next slide. Okay, on the last slide, we were given the mass of oxygen, and we were asked to figure out how much heat would be released. Now we're going to go from the heat that was released to the amount of a reactant or product. In this case, they're asking about zinc oxide. So I'm going to go from 655 kilojoules to the mass of zinc oxide. So my conversion factor in this case is going to be that 2 moles of zinc oxide is equivalent to negative 879 kilojoules. So I've got 2 moles of ZNO is equivalent to negative 879 kilojoules. So I do this one out. So they tell us that 655 kilojoules of heat are released. So it's being released, so that's going to be negative 655 kilojoules. And the heat that's going to be released will always have the same sign as the delta H in the thermochemical equation. So at negative 655 kilojoules. So now I'll use my conversion factor. So I've got negative 879 kilojoules are equivalent to 2 moles of zinc oxide. And now they're looking for the mass of zinc oxide, so I need to get the moles into grams, so I'm going to need the molar mass of zinc oxide. So the molar mass of zinc oxide is 65.38 for the zinc, 16.00 for the oxygen. So that gives you a molar mass of 81.38 grams per mole. So I have 1 mole of zinc oxide, weighs 81.38 grams of zinc oxide. So my kilojoules will cancel, moles of zinc oxide will cancel. I'll be left with grams of zinc oxide. And so when I multiply that out to 3 significant figures, I get 121 grams of zinc oxide.